Please take your seats. Our program will begin momentarily. Please welcome our MCs.
Hey. Hello and good morning.
Morning.
There we go. That's the energy I like. We would like to welcome you all here to HashiConf 2025. Now, whether if you're touching grass with us here locally or you're on the live stream, we're excited that you're here with us for these next 2 days. My name is Trevor Powell. I'm a product manager at HashiCorp on the HCP team.
And I'm Tina Greenouch. I'm a senior project manager on the professional services team at HashiCorp as well. Trevor and I will be your cloud engineering track MCs for both today and tomorrow, and along with a few other folks from our team. HashiConf is all about connecting, learning, and sharing your insights as part of an incredible HashiCorp community. HashiConf has a captivating content, engaging activations, lively network opportunities, and so much more.
Yeah. Now, before we get started, there's a few things we want to get over real quick. First and foremost, please silence the devices. We don't want to anger the demo guys this week. Also, we want your president here with us. I appreciate that.
That's right. And if you're sharing on social media today, your hashtag is #HashiConf. This year, you'll have an opportunity while at HashiConf to offer real-time feedback on all the sessions that you're going to be watching over the next few days. At the end of each session, a QR code will appear on the screen, and you can scan that code to provide feedback.
Yes, at this conference, we're a community. So this is your opportunity to let us know what you think. Your feedback is critical. All right. Also, let's take a quick look at our code of conduct. Really, we're trying to create a safe space for everyone, everywhere. And it's important that we're respectful, we're considerate, and please be kind.
We'd also like to take a moment to thank our platinum sponsors, AWS and Azure, as well as all of our, please. Thank you. We also want to thank all of our gold and silver sponsors as well. Don't forget, they are in the hub, so please visit them throughout the event. After the keynote, Trevor will go over some more specific event information, but now we want to take a moment to celebrate a very special milestone. This year marks the 10th anniversary of HashiConf. Nice. Yes. And whether this is your first HashiConf or your 10th, we're glad you're here. You're a part of a community that has shaped the future and the way we communicate, we learn, and we grow together.
Yeah, that's 10 years of innovation, collaboration, and community. We've launched products, we've shared ideas, and we built the future together. Also, if you think about it, we've also built a culture built on pragmatism, shared ideas, and a curiosity. We're all about solving hard problems in smart ways.
That's right. So before we welcome Armand to the stage to give us a view at what's next, let's take a moment to reflect on how far we've come. Please enjoy this special commemorative video to show you the last 10 years of HashiConf.
In 2015, we gathered for the very first HashiConf in Portland. A few hundred badges, a single stage, and the spark of something bigger. The first steps on a bridge we have been building ever since. Each year, the community grew. Napa, Austin, San Francisco, Seattle. Bigger rooms, brighter lights, but familiar faces always returning. HashiConf became the moment we circled on our calendars, the place we came back to meet in the middle, and it reached further than we ever could have imagined. It wasn't just an event you attended, it was a tradition you belonged to. Each event became a milestone for all of us. Vault put keys in the right hands, Boundary opened the door, and then Terraform 1.0. We announced it on live stream because we had to, and it still did. Even apart, we moved forward together. When things came back up, so did we. More people, more moments, more users. We even excelled. But through every change, the heartbeat of HashiConf stayed the same. 10 years later, the story of HashiConf is the story of us. A community that keeps finding its way back to each other. HashiConf has always been our bridge. And together, we'll keep building.
Please welcome HashiCorp co-founder and CTO, Armon Dadgar.
Good morning. Good morning. Good morning. How is everybody doing? Hopefully enjoying this beautiful, foggy, classic San Francisco morning. I'm super excited to be here. This is a very special anniversary for us. This is the 10th anniversary of HashiConf. And it's fair to say that it's a little bit larger than the first one we had in 2015 in Portland, where we had maybe about 250 people in a very, very small theater. So I think for me, what's been exciting has been kind of this event is kind of a milestone every single year we look forward to. It's the drumbeat internally for us as we think about what products we want to release. It's our opportunity to kind of bring new people into the community. It's where we do kind of our storytelling of how we think about the products and the portfolio evolving. And I think in some sense, the best part of it is the people. It's everybody here. It's the folks in this room that has made this event so special. I think many of the folks here, this is not their first or second or fifth HashiConf. There's a lot of folks who have been here for almost that entire stretch of 10 of them. And there's a small group of people in particular that I really want to highlight, which is the HashiCorp ambassadors, right? These are the folks that represent the brand. Exactly, you don't even need me to finish my sentence. You've all watched their videos, you've read their books, you've gone through their tutorials, so you know exactly who I'm talking about. But I want to take a quick minute to ask a few folks in the audience to actually stand up and celebrate 7 of the folks who have been here the longest. If you don't mind, please join me. You should be wearing special jackets, so I know who you are. Clearly being shy here. Big round of applause. Thank you all so much. Appreciate it. This conference really doesn't happen without the people, and especially our ambassadors. So find them. They're wearing cool jackets. You can't miss them. So with that, maybe shifting gears a little bit, I think what's been fun about both HashiConf and HashiCorp and this community is we sort of got to grow up alongside cloud. And what I mean by that is, you know, we started the first conference in 2015, but the company a little bit earlier than that, 2012, and in many ways we sort of grew up in parallel, right? The cloud, you know, if we think about 2006 being the moment EC2 became available, 2012 was still early innings, right? Early days of cloud, very few services, life was still simple. And we've sort of gone through the phases together, right? The early days of enterprise starting to adopt cloud, realizing the complexity and the need to really drive a level of standardization, and then getting to scale and realizing the set of challenges that come when you don't have 1 or 5 applications, but 5,000 applications running in those cloud environments. And so in parallel to that, I think you see the product journey, right? Mitchell created Vagrant in 2010, which is where this all started. From there, we go into creating the kind of portfolio of tools we know and love, the Terraforms, the Vaults, the Nomads. In 2015, that kind of culminates with the last pieces of the portfolio at the time, Nomad and Vault, being announced. And then subsequent to that, new tools got introduced, whether that was Boundary, whether that was, you know, Service Mesh, Terraform 1.0, getting into kind of the modern parts of the portfolio. And so throughout that whole time, I think what we've done is really take the feedback from this community, understand, hey, what are the challenges, right? Early days, it was about enabling cloud adoption. Then it was about how do we drive the standardization, what's required as we think about things like policy as code. And then ultimately, we get to scale. And now we're part of a larger family at IBM, continue to think about how do you help the world's largest enterprises deliver and manage at that scale, right? It's fair to say that along that same path, the complexity of cloud has exploded, right? What we started with was basically running VMs on cloud, right? It was EC2. And I think what we've seen is that explosion of now we have everything from microservices to service mesh to serverless, functions as code, and everything in between. And so it's not just that we had to embrace cloud, it's that there's a whole change in the technology landscape, the application architecture, and the complexity of the environments themselves. Of course, it wouldn't be a tech conference without talking about the impact AI is going to have to all this, but we're going to leave that to unpack that more in our vision in an AI era tomorrow. So kind of bringing it back to kind of the HashiCorp view, our view has always been that the world is going to be hybrid infrastructure, right? And I think that's more true today than ever. You're going to have multiple public clouds. You're going to have private clouds. You might have neo clouds because you need more GPU capacity. You have edge. And even now, as part of IBM, we think about IBM Z as yet another platform as part of that hybrid estate, right? On top of that hybrid sort of infrastructure is then the data and middleware that supports it. Think everything from our databases, our message queues, our data warehouses, all of the other plumbing necessary to make these applications work across a multi-cloud world. And at the very top, on top of all that, is then the automation and intelligence layers. And this has always been where we focused, right? It's what's needed from an infrastructure perspective, if we think about lifecycle management, what's needed from a security perspective, and then around us is really the application lifecycle. So thinking about everything from version control and CI/CD and the application delivery pipeline, to then the intelligent operations on top. And whether that's cost optimization, whether that's policy and security, and whether that's now going to be the next generation sort of AI-powered operations, right? So that's how we think about the need to get to this hybrid cloud operating model, is basically every enterprise struggling with having a multi-cloud reality, and how do you operationalize that efficiently, right? So for us, we like to decompose that and think about, well, what are the different personas involved? What are the different roles and tasks and jobs to be done? And how does that change at different parts of the phasing, right? So day 0, day 1, when I'm just building my initial application and getting it to cloud, it's a very different set of concerns than when I get to day 2, day 3, day 4, managing that application through its life cycle, right? And I think in the early days, that focus was very much day 0, day 1. Let's get things in cloud, let's do the adoption. Versus we get to standardize and we get to scale, our bigger challenge is, well, how do I maintain 500 or 5,000 applications running in cloud? So jumping right into it, right, I think starting with Packer, I think very much starts to look at that image building process. How do we not only day 0, day 1 build those images, whether we're talking golden images that are base operating systems or maybe application-specific images. We need to build and version and maintain those things. But you get quickly into the day 2, day 3 problem, which is great. I built a golden image, and now I have a vulnerability. I need to build a new version, and I need to patch all of the instances in my environment. I think one of the biggest challenges we've seen is how do we actually know what's running in all of these images? So one of the things we've been working on is really how do we bring things like better SBOM storage and artifact visibility into, well, what's actually running in those images? So this is a new feature enhancement to Packer where now we can actually, as part of the image build process, take a snapshot of that build of material. And as part of it, inline, you can see this block here. We can actually have an HCP SBOM declaration where we can upload the SBOM as part of the artifact. So what that lets us do is not only build the artifact, but then go ahead and index what's running in that. So that then we can surface it up as part of the metadata. So if we go into the Packer UI, now we can see not only the image, but the actual contents of what's a part of that image, what packages, what versions, et cetera. What this is going to enable us to do and where we're going to build on top of this is then to be able to automatically correlate that against things like CVEs. So not only do you know you have this version running in production, you know what packages are in it, but you also know that you're running an impacted version of OpenSSL. You should probably go rotate that image. Right? So all of that is part of thinking about those day 2 kind of operations. Now, shifting gears to Terraform, we have the same sort of a challenge. It's not just about creating the infrastructure and deploying it day 0, day 1. How do you maintain and build it over time? And so this has been a challenge we've talked about for a long time, right? I think for most of us, we have many, many environments, dev, stage, prod, UAT, et cetera. And so this often translates to a lot of different Terraform workspaces, right? We have the same configuration, reapplied multiple times. And so this brought complexity of how do you manage Terraform across these multiple environments. We've talked about stacks as the solution to this. And we've been running that in public beta for a little while. And for those still unfamiliar with stacks, the idea is basically to have Terraform have a first-class understanding of both multiple deployments, so think about environments like dev, stage, prod, but also multiple component layers of our stack, so core network, middleware, application, et cetera. And now we can manage that as a single management unit. I'm excited to announce that at very long last, Terraform is finally going generally available with stacks. So I'm not going to spend too much time on this because there will be a session on it, but there's been a bunch of enhancements since the public beta, a totally revamped UI, really thinking about a much larger scale of environments, components, and changes, enhancements to supporting new backends like Azure DevOps and Bitbucket, better support for the self-managed agents to be able to run it in your private environments. So a bunch of improvements have gone into Stack since it went into public beta, but there will be a session right after the keynote on track 1 over on this side of the room. So if you're interested, stay in the room and head to that side. And there'll be a lot more details of that. Shifting gears from there, I think the other challenge we've seen is, many people who started on their cloud adoption journey didn't start with infrastructure as code. I think many of us have seen the classic, lift and shift of let's take our data center, our lease is ending, and we'll kind of click ops our way to the cloud. Well, it turns out there was a lot of ways to get to cloud, right? You could have click opsed in a portal. You could have, gone through a ticketing mechanism, through a self-service catalog. Many people wrote their own scripts with SDKs or directly to the APIs. So there was many ways to get to cloud, not all of them equally scalable once you got to cloud. And so I think one of the biggest challenges was always, OK, great, maybe I have 20% of my estate managed by Terraform, but what about the other 80% that I click opsed? How do I fix that? How do I bring it under management? So this has always been a big challenge. And I think we've done things like Terraform import that allows you to do it one at a time. But there's always been this question of how do I do it at scale in a bulk way? So super excited to announce a new feature today, Terraform Search. So looking at Terraform Search, I think this has kind of been the long requested feature probably since we introduced Terraform 0.1. It might have been like the second ticket that was created on GitHub. And the idea was basically, can you just point me an environment, search the environment, find the things that are there, and then write the Terraform code for me? So in this UI, that's what you can see that's basically happening. We've selected a resource here, and we're basically auto-generating the Terraform code corresponding to that resource and enabling you to just import it. But let's look at a demo in terms of how does this actually work. So as you'd expect, there's a declarative search syntax. In this case, we have a list block here asking for VM instances. And so we can run Terraform and basically provide that input file. And what we'll see is it found a number of instances that will correspond to the UI as well. So we can see it in the CLI or the UI. And we can see it found a bunch of instances here. And then based on that search, we can actually select the set of resources that we want to be able to import. And it's telling us here what's managed or unmanaged currently by Terraform. And effectively, then that code gets auto-generated. Right? So this corresponds to the resource. It uses the import syntax. And now if we paste that in and actually run Terraform, what you would hope to see is that Terraform thinks everything is aligned. There's nothing to be changed. We're just going to import existing resources under management. And we can see that that's exactly what happens. It sees that, hey, there's 2 resources to add. Great, we can run Terraform apply. Now we bring those in and run them as part of Terraform managed resources, as opposed to maybe they were click opsed previously, right? So I think this has been long awaited, super excited about this feature. It is now available in public beta. So give us feedback, looking forward to it. Now, if we go back to kind of the thinking of sort of the origins of Terraform, in many ways it was born as kind of a cloud-native tool, very strongly held views around immutability. And I think this translated directly into sort of being a very good day 0, day 1 tool. It's awesome at provisioning. It's awesome when you get to day n and you want to deprovision because it models CRUD lifecycle very closely. I think an area that was always trickier was some of those day 2, day 3 things where what happens if I need to touch a resource, but I'm not really modifying it, right? I want to apply a change to existing things, but there's no change to the Terraform definition. That was always an area where people got creative. And I think we saw all sorts of fun things like null resources and ways of sort of making Terraform run things in that day 2, day 3 environment when it wasn't actually touching and modifying a resource. I think this always created the sense that something was missing from Terraform, right? Like it was sort of, you were kind of fighting its core paradigm. It didn't have a natural way to lean into those sort of workflow challenges. And so we found creative workarounds, but it felt a bit icky, right? And so we wanted to sort of address that ick and say, OK, how do you fix some of those day 2, day 3 workflows and make it feel like a native part of Terraform? So something I'm super excited to talk about today is a new capability we're calling Terraform Actions. So what are Terraform Actions? Let's start off with maybe the more simplistic or more familiar example. right? So Terraform action, for one, is a new first-class block. Like a resource, like a data, you can see we're modeling an action as a top-level item within the HCL syntax. But now you can actually see a slightly different syntax within an existing resource on an action trigger. In this case, we're saying after the resource is created or after the resource is updated, we want to run a particular action. This is what you can think of as a resource-linked action, right? It's a thing we want to run. It's an action we want to invoke, but it's linked to the lifecycle of a resource, right? That could be before create, before modify, after modify, before destroy, after destroy, right? Any of those sort of lifecycle points where Terraform's touching a resource, we might want to invoke an action. What this starts to let us do is have sort of provisioners plus, right? Super provisioners, right? It lets us hook into every point within that Terraform lifecycle management and invoke actions and connect into other parts of our ecosystem, right? In this example, we're connecting into Ansible. So after we're provisioning or after we're updating, we want to go ahead and invoke a convergence run of our configuration management, right? So this gives us one use case where we're taking existing provisioners and expanding it to a new set of workflows that weren't previously possible to hook into from a lifecycle perspective. And you might want to do this to do things like set up a VM after provisioning. Before you modify a database, maybe you want to take a backup. After you delete a resource, maybe you want to clean up records out of your CMDB, right? So all of these have been things that we've seen people want, and they've gotten clever in kind of forcing Terraform to do it. This gives us a first-class mechanism. But then let's look at where this starts to diverge pretty heavily from providers, right? So this is an action that is sort of not linked to a resource lifecycle at all. It's sort of an ad hoc action, right? In this case, we're saying the restart of a web service. So this is existing infrastructure. We're running a VM. We're not changing the configuration of the VM. There's no reason Terraform would touch it. But it might be that that app crashes for whatever reason. It has a memory leak. It has an application bug. We might want to come in and just run this action 2 months after we provision that VM. And there's nothing that Terraform needs to plan or apply because the VM already exists, but we just want to use Terraform to invoke this action day 3, right? So this is a totally new workflow that starts to enable Terraform to now solve some of those day 2, day 3 kind of workflow gaps in a way that's native to the language. It fits into that declarative pattern and allows us to deeply integrate with our runbook systems like Ansible, right? So this can start to be used for all sorts of things, right? Thinking about running a script on existing infrastructure. Think about upgrading a hardware firmware. Think about clearing log files. All of those kind of things don't involve changing the underlying resource, but you kind of have to go run a set of imperative actions. So there's a whole universe of things that we want to be able to support with this, right? The architecture of how actions works is really built on top of the Terraform provider ecosystem. So any of the Terraform providers using the Terraform SDK can start to expose platform-specific actions, right? You might have a cloud-managed database, for example, that exposes a snapshot or backup action. You might want to talk to your Kubernetes cluster and do something imperative like restart a pod, right? That doesn't fit naturally into Terraform syntax. You might be using automation tools like Ansible to run playbooks that you need to run day 2, day 3, well after the infrastructure is provisioned. All of those are the kind of things that are now become possible with Terraform actions. So to talk a little bit more about how we're imagining bringing Terraform and Ansible together for a better together kind of an experience, I'm super excited to welcome Hisham from Red Hat to join us on stage and share a little bit more. Please join me in welcoming Hisham. So much for joining.
Thank you. Great to see you.
Well, thank you so much for joining and being here. I'm super excited about Terraform Actions and what it means for the Terraform integration with Red Hat.
Thank you.
But maybe just to kick us off, maybe give us a quick introduction to your name, your role, and what you do, and what you're responsible for.
Yeah, thank you so much. My name is Hisham Murad. I'm part of the Ansible business unit at Red Hat. I focus on technical marketing, anything to do with Ansible, Ansible on cloud, and I also work on the Hashi integration around Terraform and Vault as well.
Well, thank you so much for being here. Really excited for this. So before we dig into sort of the better together story with AAP, you know, obviously we've been talking about, you know, Terraform Actions and how to bring these two platforms for almost well over a year at this point. So it's something that the teams have been working together for quite a bit. Maybe you could share just a little bit more about sort of how you've been thinking about it from the Ansible side and how these kind of brings the two tools together.
Yeah, great, thank you. So with Terraform and Ansible automation platform, we can consistently build, deploy, and manage infrastructure across its entire life cycle. Now, this is wonderful, right? But now, with the introduction of what Armand just announced around Terraform Actions now expands automation from day 0 through day 1 into day 2 as well. And it triggers Ansible Automation Platform to perform that ongoing automation.
Awesome. So maybe going back to some of the use cases for Terraform Actions, where do you see Ansible playing into this?
So one of the things that you can do with Ansible Automation Platform is listen in real time to different events. And with Terraform Actions, we can listen in real time to these events and capture those events through something called event-driven Ansible. And that's just a component of the Ansible Automation Platform. And so once we receive those Terraform Action events, we can then act upon them, trigger the automation that's being requested through that event.
So I think what might be exciting is let's move from maybe the slider to the demo, and I think make it a little bit real for folks. So maybe walk us through, what does this actually look like here?
Yeah, so really quickly, just to kind of set the stage a little bit. So what we're going to show here is Terraform Actions working in concert with Ansible Automation Platform to trigger some additional automation. So another little brief moment here. We have some already Terraform managed infrastructure already exists in AWS, and we're going to make some modifications to trigger those actions.
So
all right, so what we're seeing here is a snippet of code. And in this snippet of code specifically, what we're doing is Terraform is actually adding the inventory host into Ansible Automation Platform. Right, so that's what that first portion of doing is adding it. We have all the variables around it. And then we're triggering an update lifecycle management action, excuse me. What is that update Terraform action? Well, you see it on this screen here. So what this is saying is, hey, go to Ansible Automation Platform, run a job template. That job template is called Update AWS Provisioning AWS job, and then send that over to the event stream in Ansible Automation Platform. Remember, that's where Ansible is listening in real time. Right? So now what we're going to do to trigger that, we're going to basically commit the code change. Let's say we have this application, right? And what we're going to do is trigger a change here from 5 to 25. We're going to commit that change. And as we commit that change, obviously that's going to trigger the Terraform plan. So here we are now, we trigger in the plan, and the plan's all completed. And now what we want to do is apply that plan. So we're going to go ahead and apply that plan. And as you can see, the apply completed here. We can see all the resources. We actually are printing out all the IPs of these VMs, the EC2 instances that we created. But remember, we're also triggering actions as part of these resources. So if we just take a step back a moment, and what we're going to see is we want to show you here a snippet of what the Terraform action looks like inside the HCP Terraform user interface. So you can see that here. Here are the details. This is what we want you to do, and post that over to the Ansible Automation Platform event stream. So here we go. We got all that. What does that look like in Ansible Automation Platform now? So in Ansible Automation Platform, remember, we have the event stream. It's listening for all these Terraform actions that are coming in. You're going to see that number there, that the events received. That number is going to increase automatically, which it just did very quickly. And now, to prove that this is all working, let's go ahead and check this Terraform managed inventory. And just to show you that all these EC2 instances got created in AWS, and now we have all those details in Ansible Automation Platform in the Ansible Automation Platform inventory, which now means Ansible can go ahead and do automation against all those resources. So you can see now that the jobs are all running, right? So all the jobs are running. And just to show you what the job details may look like, we're going to expand one of these jobs. And so here's a simple job, right? So what this is doing, it's waiting on the EC2 instances to come alive, and we are accessible via port 22 over SSH. And now that it's there, we're actually installing some prerequisite software that we need, making sure everything's there that we need. We're deploying a firewall. We're configuring the firewall. We're restarting the firewall. So this is, again, a simple example, but just to show you that we can do this. And really, in terms of what you can do in an Ansible playbook or an Ansible workflow, the sky's the limit.
This is awesome. I mean, I think this exactly addresses, I think, some of the questions we've been getting since day 0 of the acquisition, which is,
Absolutely.
How are you going to bring these together? How are you going to synchronize inventory between the systems? How are you going to make it seamless to go from Terraform doing the provisioning to Ansible doing the configuration and runbooks? And so I think this has very much been part of the vision of how do we make this feel like a first-class experience.
Absolutely.
So thank you so much. I think let's switch gears into, I think that was the kind of simple demo of like just basic Terraform, just basic Ansible together. I think the bigger question has been, how did these things come together into a bigger combined IAC platform? And so I think when we look at kind of, zooming out a little bit, there's obviously a lot of different tools at play, a lot of different personas at play. I think we've always felt that both Terraform and Red Hat's Ansible have been more of an ops tool. They're more designed for platform teams, operators, SRE type folks. But it's not necessarily ideal if you're sort of a traditional IT background used to maybe filing a ticket and someone else is kind of doing it for you, or if you're coming from a developer background where maybe you want to focus on app dev and you don't necessarily care about the details of how cloud infrastructure is managed. So I think when we take a step back, we think about Terraform and Ansible as kind of part of a core IAC automation platform, really designed for the ops teams to own and operate and work directly with. But then how do we create different front doors, whether that's coming in through a ticketing mechanism, if you're used to more of a traditional ServiceNow maybe interface, if you're coming in from a traditional IT ITIL background, or if you're a developer who wants more of a modern internal developer platform, where you might be coming in through a backstage type interface like Red Hat's developer portal, or you're using HashiCorp's Waypoint to provide that kind of low code, no code experience. So the goal is that these things are not necessarily just standalone, but that they're part of a bigger platform experience that we're trying to deliver, which really says how do we cater to these different personas and the different experiences they want, but underpin everything as infrastructure as code to really deliver that across the hybrid estate. So please join me in thanking Hisham. Thanks so much for joining us and sharing the vision together here.
Thank you, everybody.
Thank you so much.
Thank you.
Thank you. If you want to learn more about that integration, I recommend visiting the Red Hat booth in the hub. And then there's also going to be folks able to talk about Terraform actions as well in the zone. So please go ahead and chat with the folks there. I'm sure excited to talk in more detail. So, another key piece when we take a step back and look at that life cycle of infrastructure is really as we get into the later stages, it's the cost management, right? How do we not only deliver this infrastructure, but do it in a way that's cost efficient, cost effective? And I think this has always been something we looked at of how do we bring that more in line to the provisioning experience, right? At the point of change, how do we make it clear that, hey, there's an opportunity to optimize? So this is something where we've been working closely with the Cloudability team on improving run task integration. So run tasks are really an ability to bring in additional context and information into Terraform's execution path. And with enhanced run tasks, we're trying to bring in a lot more state. So in this case, you can see feedback from cost estimation, cost policies, cost recommendations, all being surfaced in line as part of a plan apply cycle. So this is part of enhancing run tasks, but as part of going deeper as well with Cloudability to try and shift that FinOps control into the actual path where we're making changes rather than sort of the classic whack-a-mole we see where we spin up and make a bunch of costs and then a FinOps team has to come and play cleanup afterward. So we can see what it looks like in the Terraform UI. From there, you can actually click into it and go deeper into the Cloudability UI, where you could drill in much more specifically and get the additional detail on those changes. Now, shifting gears, obviously we've been talking about partnering with Red Hat, partnering with Cloudability within the IBM portfolio, but we also work closely with partners outside of the family. So I'm super excited to announce a partnership with Google Cloud Platform as well in terms of bringing native Terraform support as part of the Google Infrastructure Manager. This allows the latest versions of Terraform to be used as part of a managed service as part of the Google Cloud Infrastructure Manager, and that then underpins a bunch of automation and AI capability delivered by Gemini on top of that. So there's going to be a session on this in the business track tomorrow. If you're excited and want to learn more about what Google has working here and what we're doing together, I'd recommend checking out that talk tomorrow. So shifting gears a little bit, right? We've talked about a lot of infrastructure updates, but obviously we spent a lot of time thinking about security lifecycle as well. On that side of the house, you similarly have multiple personas. You have security teams, you have platform teams, you have development teams. Each of them cares about a different set of things, and each of them is touching the life cycle in different ways. I think where a lot of this starts and where we've spent most of our sort of time is really how do we solve that secret sprawl problem of most enterprises, right? We continue to see this problem over and over as the top issue where credentials are everywhere, right? They're in everywhere humans work, they're everywhere applications can log to. So how do we solve this issue? Obviously, Vault plays a big role in providing us a solution of where do we store these things. But further up the stack is finding out where those secrets are to begin with. And so that's where we introduced Vault Radar as our secret scanning and detection tool. And so we're continuing to improve that experience as well. Part of that is how do we shift left and catch the secrets before they're ever committed to a version control system. So this is where we've enhanced the IDE plugin so that we want to catch it at the time the developers are writing the code before they've checked it into their actual version control. At the same time, we've made enhancements to our Confluence integration as well. So let's take a look at what this looks like. So if we jump into a demo, we might have a developer writing some code. They're connecting to a database. So they might write a quick little Python script just to make sure everything is working. And as developers are wont to do, they might hard code the developer username and password as part of this script, right? And so now the moment they save that file, they're going to get an error message that shows them, hey, you've actually hard coded a credential. You probably shouldn't do this. But more than tell them what they shouldn't do, how do we actually give them a remediation option? So this lets them directly copy the secret and import it into Vault and do that inline without ever having to leave their IDE. So they can provide some details like what's the name of the key, where do they want to store it in the Vault, and basically without even having to leave their environment, they can put that credential in Vault. So then we can actually see if we go to the Vault UI, if we drill in, we can actually find that credential has been created. So there's a new secret, and it has the value that came from what the developer had hard-coded into their IDE. Now, they might not stop there. They might find out that for some reason they can't connect to their database, so they're going to open a ticket against their database admin and say, hey, I can't connect. Here's my reproduction code, and that happens to include the username and password as well. I'm sure none of us have ever seen one of these tickets. And so now if we go into Radar, we'll see that by part of having enhanced scanning of Jira, we'll right away flag that there is in fact a username and password in your Jira, and you don't probably want that to be the case, right? So now we can mark that as triaged here as well. So this is part of the ongoing focus of Radar of how do we make it sort of shift as far left as we can into the pipeline and catch it as early as we can, but how do we expand the number of sources that we're scanning to try and catch all of the places where these things might end up getting leaked. The unfortunate reality is, as defenders, we kind of need to protect the secret everywhere. As attackers, we only need to find it once, right? So shifting gears, I think the other side of this then becomes how do you actually prevent having to give the credential out in the first place to the end users, right? So in this case, the developer might be trying to debug something with the database, but why do they ever need to actually have the database credential to begin with, right? This has always been the goal for Boundary. When we think about humans accessing privileged systems, what we really want to do is start with the human identity, right? So we might say, great, Armon's a developer, he's a member of HashiCorp, he's authorized to talk to that database. And we want to use systems like Vault to broker those credentials, but not necessarily ever give me access to it. Or if I have to have access, use very dynamic, short-lived credentials that can be revoked. So as part of that, we're sort of expanding the set of protocols Boundary can transparently inject a credential into. A long requested one has been Windows Remote Desktop Protocol, right, or RDP. This allows users to access RDP systems, much like the way they SSH into Linux VMs, but to do it without ever having to see or know the credentials, right? So what does that actually look like, right? So using Boundary, we might be able to say, great, the user has access to a number of Windows systems. In this case, we're going to pick one of them and try and establish an RDP connection to it. But if we look at how we've set it up, the user is actually not providing a username or a password for this, right? So when they establish that connection, Boundary's transparent session is basically hijacking it, using the user's identity, and then talking to Vault to create the dynamic credentials necessary for that session and injecting it into that session. But the user never sees it. So now they can't create a Jira ticket with it. They can't hard code it into their scripts. So that's really where we want to go, is that the user should ideally have access to the systems they need, but not have access to the credentials that they could expose, right? And so this is part of making that much easier. This brings support for RDP, and this is a building block for delivering RDP session recording later next year as well. So underpinning those dynamic secrets is Vault, right? We're providing human to machine with Boundary, but machine to machine brokering and dynamic secrets is being managed by Vault. And in October, we're releasing the next major version of 1.21. As part of that, there's a number of major updates. One is bringing in rotation support for Azure static roles. So now you can define roles within Vault and programmatically rotate them. So again, part of that shift of how do we go away from long-lived static credentials to really having a set of dynamic credentials that are being rotated constantly. At the same time, we're sort of leaning into better PKI and dynamic certificates, dynamic identity for applications. And SPIFFE is a common standard for this, right? Vault has long supported SPIFFE through the JWT and PKI engines, but now we're making this more first class and adding more sort of syntactic sugar to support the SPIFFE protocols. This enables two key workflows. One is SPIFFE-based authentication. So a workload that has a SPIFFE identity can use that to authenticate against Vault. This is basically based on the PKI-based authentication, but adds the sort of syntactic sugar for it. And so then that thing can trade it in and get a Vault token and use that to access other services and systems that it needs access to. At the same time, we're also adding support for SVID minting. This allows you to take your existing Vault token and get back a spiffy identity that you can use for system-to-system access. This is becoming a particularly important pattern when we talk about these next-generation AI workloads, right? How do we have agent-to-agent or user-to-agent communication patterns where we have a strong cryptographic proof of we know the identity of our caller, and we can cryptographically verify that. And Spiffy provides a good standard for doing this, built on top of standard protocols like OIDC, right? Next up is VSO, Vault Secret Operator's Protected Secrets. So as we integrate with Kubernetes, the Vault Secret Operator makes this a lot easier. Protected Secrets is a new way of actually delivering secrets directly to the pods in a way that bypasses potentially having them be stored unencrypted in etcd as part of the secrets object. So this is an enhancement to the operator and an enhancement to how we integrate within the Kubernetes ecosystem to make it seamless and more secure and avoid potentially having secrets exposed in plain text in transit between systems. Now, when we talk about our managed Vault offering, HCP Vault Dedicated, we've been continuing to support deeper and richer networking integrations as we try and integrate with more complex environments. One of the goals of this has been bring your own DNS. So in a lot of environments, if you need custom DNS resolution, this allows you to, as part of peering your Vault into your network, also delegate the DNS to your own custom resolvers. So we supported AWS already. This adds Azure support for that peering as well, right? In AWS, a long requested feature has been the ability to do private link. So if we don't want to necessarily peer our networks, but we still want a private network endpoint to talk to Vault, this solves that problem. We can have Vault running in a dedicated VPC, but then you can create a private link to talk to that over a tunnel connection without having to expose Vault to the internet or have your traffic leave your network. The next big one is Vault Secrets Inventory. I think a long requested feature has been, don't just store the secrets, tell me when were they last used, when were they last rotated, has nobody accessed this thing in 2 years, is it stale and it needs to be rotated? And so all of that is a part of bringing enhanced reporting and dashboarding to Vault. So this is coming first to HCP Vault Dedicated, the cloud offering, and now you have access to much richer insight into the usage patterns and what set of secrets are actually inside the Vault. Next up, I think we've always focused on how do you get to a true integrated platform security story, right? The best way to use Vault is for it to be invisible to the developers, right? You want it tightly integrated into the platform and just a part of the plumbing without someone having to touch it. And so we have a long roadmap planned with OpenShift where with each version, we're sort of incrementally deepening that integration and making it more seamless for users. As part of the latest release, we're really working on a certified set of CSI drivers that allow Vault to basically transparently be used by the applications to surface the secrets and have them presented as basically a virtual volume to the application, but without having to really interface directly with Vault. Makes sort of Vault an invisible part of the platform. What does this actually look like? We'll take a quick look here, right? So if we're in OpenShift, we can see we have an official operator that's installed. There's an official Helm chart as well to actually deploy Vault onto the cluster and get it quickly running. And then from there, we can actually see that, great, these components are running within our Kubernetes cluster. And so if we actually want to now deploy a workload, what we would hope is that by deploying the application, the operator should do the heavy lifting for us, right? What we'd want is that the application is kind of deployed in a standard way, right? We can see a user kind of going through, deploying their application. And the operator should transparently detect the app is getting deployed, automatically set up the CSI driver. The CSI driver should fetch the right set of secrets for the application. And then the application, it should just materialize and show up as basically a volume, right, or an environment variable. And we can see in this case, great, if we printed that environment variable, the value just shows up, right? And so that's exactly what we want. From the user's perspective, they're just deploying their app. The fact that the secret showed up is great. It's convenient. They didn't have to think about it, right? That's exactly how we want this to work. Right? So if we kind of look back on the last 10 years, it was really been this progression of cloud programs from the early days of enabling enterprises to adopt cloud, to realizing the challenges of how do you standardize many teams going to these cloud environments, to ultimately how do you operate at large scale in a day 2, day 3 environment, where you have to maintain this huge surface area of applications. And that's very much where our announcements have been focused, is how do we start to enable organizations operating at scale, because that's where we're headed as an industry. So you see that reflected in many of the updates. How do we think about artifact management and vulnerability management with Packer? How do we manage complex estates with stacks? How do we import these ClickOps things with search? How do we automate day 2, day 3 activities with Terraform Actions? And then similarly, I think on the other side, great, we have solutions like Vault, but how do we find all the secrets in our environment and bring them in and stop people from leaking them? And then how do we continue to deepen and automate what we're doing with Vault to more surface area, more platforms? And ultimately, with tools like Boundary, how do we eliminate the need for end users to even have those credentials to begin with? So super excited about all of these announcements. There's going to be great sessions going into more detail. I think as we look into kind of what's in store for tomorrow, I think we're just starting off a parallel journey now with our AI programs, right? In many ways, I feel like we're sort of back to the early days of starting adoption, starting experimentation, starting to figure out how do we operationalize these things. And that's going to be a journey in the same way that cloud was. So excited to chat more about this tomorrow. So come back and please join us. But in the meantime, I hope you enjoy day 1 of HashiConf. And let me welcome back our MC, Trevor. Thank you so much.
Hey everyone, big thank you to Armand, also our special guest Hisham from the Ansible team. Awesome keynote. A lot of tasty morsels in there if you were listening. Something that really stuck out to me was actually the ACP Packer SBOM announcement. Really makes me curious about how this will link to tomorrow's keynote. My name is Trevor Powell. I'm Senior Product Manager, and I'll be your MC for Cloud Engineering Track number 1. Okay, that's today and tomorrow. And I have some few housekeeping items I want to get to you all before you get to your sessions. All right. First up, we have 5 tracks running simultaneously. We have 2 cloud engineering tracks. These are technical deep dive sessions based on the keynote that you heard today and tomorrow. They'll be located in this room. To your right will be cloud engineering track number 1, and to your left will be cloud engineering track number 2. Also, there'll be 2 tracks in the Gateway Pavilion. You'll have your business track, that's focused on cloud automation strategy, and there'll be a hallway track. In addition to this, there will be our on-hands lab. This will be in Storehouse Building D. Right? Now, a few of these tracks will be silent tracks. It might be looking at me kind of crazy, but hear me out. So if you've ever been to a museum and you put on headphones so you can hear what's going on, it's going to be like that. So you can hear, but the person next to you can't. We'll be handing out headphones before some of these tracks, and each headphones will be pre-programmed for a certain channel and color. Now, don't worry. We're going to go this all over again. We'll explain it with you well, and we have a great production team in the back to be able to help you out. All right. Also, we have free on-site certifications. You can sign up for associate level exams by visiting the HashiCorp zone. And backed by popular demand, we have our Women in Tech Luncheon. Now, you get to hear, yeah. So let me break it down for you. So you'll hear from VPs, community founders, product leaders, all about the systems that they built, broken, and rebuilt, okay? Also, you have a guided networking to be able to have community with other women and allies. This is going down today during lunch in Storehouse Building D, so you should pull up. Okay, that's it. Now, I'll see some of you back here at 10:30. For everyone else, have a great HashiConf. Peace. Hello, hello. All right. Hello, everyone, and welcome back. This is Cloud Engineering Track number 1. If you can, put your headphones on. This is Cloud Engineering Track number 1. This is where all the cool sessions are, just by the way, in case you're wondering. And also, I got to represent for my shirt here. My name is Trevor Powell. I'm a senior product manager at HashiCorp, and I'll be your MC for Cloud Engineering Track number 1. This is today and tomorrow. Okay. Now, again, I said Cloud Engineering Track number 1. If you're looking for Cloud Engineering Track number 2, that's channel 4, the purple channel. It's on the other side of the room. Okay? So if you're looking for the other track, it's okay, no shame. Feel free to move over to the other side. We won't be watching you or looking like that. It's totally fine. Okay? All right. And if you need any help with your headphones, like you can't listen or you can't hear me right now, please work with our production staff in the back. They'll be able to get you going. Okay? All right. Also, I want to let you know, please scan the QR code on the back of your badge. This is a way where you can get the full agenda about what's going on today and tomorrow. So now we're going to review the sessions for just today at this track number 1. All right, we'll have morning sessions where this morning we'll go through all things Terraform. We're talking about the release of stacks. We're also going to talk about how Terraform and how an internal developer platform can be integrated. And we're going to talk about World Bank and how they use Terraform to achieve deployments, ensure their security and efficiency in cloud transformation. Then we'll have lunch from 12:30 to 2. After that, you'll hear about how you can benefit from integrating Ansible, Terraform, and Vault in a complete infrastructure lifecycle management for hyper-cloud automation. Then we'll hear from Air France. They'll talk about how they were able to successfully navigate cloud transformation. Also, you'll learn how Nomad can be used as a foundational layer for data center cleanup. All right, so we got a lot coming out for you all. All right, and then tonight we have our special evening social. You're all invited. Just tell me you know me, I get you in, okay? So more on that a little later at the end of the talk. All right, and now enough tell, more show. Here to talk about and introduce Terraform Stacks is here. Please welcome to the stage HashiCorp's Jacob Plick.
Thank you, sir. It was 3:12 a.m., the kind of hour where time feels broken, too late to still be working, too early to stop. I was sitting under fluorescent lights in an empty office, remoted into one of our patching servers, fingers crossed, running these VMware PowerCLI scripts to patch infrastructure I didn't build. And no one really knew who actually owned it. Oh, but when it broke, everyone knew who to blame. Hi, that's me. There were no policies, no Terraform, no real feedback loops, scattered credentials that probably lived in Excel spreadsheets, and that awful pit in your stomach only cured by the vague hope that if I copied the last working command and hoped long and hard enough, maybe the fulfillment center wouldn't call me at 5 in the morning and tell me something was broken. That the difference between success and total oblivion was a comma. It's a true story. That was normal for me. And the thing is, many of us still live in that kind of normal. And that's because for us, the path to production is dark and full of terrors. It's the surprises you didn't plan for. It's the configuration drift you discover at the worst possible moment. It's the access controls, the rollbacks, and the organizational politics that turn a simple deployment into a nightmare. So how do we navigate this? How do we find a clear path through the darkness? We do it by embarking on a hero's journey. Now, sure, we'll talk about some new features in Terraform, but there's a story here. A story about the challenges that we face and the mentors we find and the new tools that we gain that help transform our dark path into a really clear one. That journey, by the way, is your journey. You are the hero who is called to bring clarity to the chaos. And like any hero's journey, it begins with a backstory. So, hello, HashiConf. My name is Jacob Plick. I use he, him pronouns, and for the past 15 years or so, my career has been a deeply personal journey through the infrastructure world. Starting out as your classic desktop support in the sysadmin world, working my way up into a senior SRE role, moving into a pre-sale solutions architect role, talking about reliability and chaos engineering, and then eventually, in the last several years, in a developer advocacy role, talking about observability stories and process automation. And now I'm a senior TPM here at HashiCorp, which, if we're being honest, is just still code for I get to tell cool stories about infrastructure to people like you all. Speaking of stories, fun fact, I'm actually immersed in writing an epic fantasy novel on the side. And that creative journey has led me really deeply into studying things like narrative design, understanding how compelling stories are built, how heroes are formed, and how challenges are overcome. It's through that unique lens that I realized that there was a fascinating, often untold story right in front of us in our daily work. The story of infrastructure itself and our journey through it. So this is me, blurred out, much less gray hair, half lit. I remember having to wave my hands in the air to get the lights to acknowledge my existence. 5 hours earlier, 10 o'clock on a Wednesday night. Back then, I worked overnight shifts from 7 p.m. to 7 a.m. And patching systems on Wednesdays by myself was just normal. Over 10,000 servers in the enterprise by one person. I didn't know Terraform existed yet. I think back then, that's right around the time that board game, Terraforming Mars, was released. That's as far as I went back then. I was running those scripts against infrastructure I didn't build and no one wanted to maintain, because who had the time? So much so that the week before I took it over, I found out we were only patching production. Dev, QC, at least a year behind, sometimes never patched. no one wanted to own it, and production had to be patched for PCI compliance. Oh, and verification was really easy. Just wait for all the red alerts to clear, and if they didn't, log into those servers and then see what services still weren't coming up for whatever reason, restart those or the boxes again, because surely this time will be different. What's that saying about sanity? And every time something broke, I'd scramble to find the right log file, the right credential, the right duct tape. That wasn't DevOps, is what I was advertised as. But that was more like survival. It was the beginning of a classic case of on-call hero burnout. The systems worked because one person was willing to sacrifice their nights to be the hero. But as we know a lot better today, that kind of heroism isn't sustainable, and it certainly doesn't scale. The funny part, at the time, I thought I was being efficient. I got us all caught up patching-wise in those lower environments, and now I look back and realize I was being held together by institutional memory and duct tape. The systems worked until they didn't, but we weren't solving any problems. We were just surviving them. But this image, this story for many, is still today what ownership looks like. We've all been on this journey with infrastructure as code, and it felt revolutionary, right? It was our Bilbo leaving the Shire for you Hobbit fans out there. That was our moment. We were stepping away from manual commands and into a world of version control and automation. But here's the hard truth. Many teams take a few steps. Maybe they write a module or two or three, and then they go right back home to the Shire. This isn't about laziness, though. It's about exhaustion, about the fear of unknown complexity. It's about an unclear return on investment. Too many organizations started this journey over the last decade or so, but never truly committed to it. The next leap for us isn't just technical anymore. It's emotional and cultural. And we need to talk about why so many of these journeys stall out and what it takes to finally commit to that path. And we have to ask ourselves, why didn't we finish this journey? It's because it wasn't the code. It was everything that we built around it. The real problems were a lack of support and organizational safety to see it through. Who's supposed to be the hero here, really? Now, the developer's pain is the catalyst, sure, but the SRE and the platform teams are the ones who must lead the way. So this talk is about the path forward. It's not about just starting the journey, but what happens after that, what happens next. About how the newest features in Terraform are the upgraded tools that you need and the mentors that you need to overcome the next set of challenges on that path. So eventually, something had to change, right? Because duct tape doesn't scale. You also can't build a sustainable business on a process that no one trusts, if the process even exists. And when things inevitably failed, it wasn't a learning opportunity like we're learning about in the LFI, the learning from incidents conversations we're having. It wasn't a learning opportunity. It was just this silent chaos. This kind of normal is what has to end. This is the point where the hero, having seen the limitations of their existing tools, realizes that they need a new, upgraded toolkit to continue this journey. But again, we all took that first step outside of the door with infrastructure as code, but it didn't solve the entire problem. It gave us repeatability, but it didn't solve delivery. And many of us got stuck dealing with the monolithic configurations, the complex dependencies, and the brittle custom scripts creating chaos somewhere between merge and production. This is where the next chapter of the Terraform story begins. Again, not just about writing code, but about creating a clear, trusted, and predictable path to production. About achieving clarity over control. So, if clarity is our goal, where does the journey to achieve it actually begin? It begins with the most fundamental moment in our world, our call to adventure for every infrastructure hero. A developer needs infrastructure to ship their code. Platform team gets the call, naturally, and the way we respond to this defines everything. But that seemingly simple request is never actually simple, is it? Behind that request lies the true challenge of our journey, that beast that we all have to face. That's the dragon in our path, or trolls if you like The Hobbit. Modern applications aren't one thing. They are a complex web of these interdependent components. A request for a new service might mean coordinating changes across networking, databases, multiple application services. Trying to manage this with a collection of these disconnected workspaces is where the real terrors on the path to production live. It leads to things like drift, like errors, and painful, slow deployments. This is the complexity we have to tame. So, how do we solve that problem of complexity? How do we achieve clarity? Well, that's where the first new tool for our hero's journey comes in, as Terraform Stacks, as you found out, generally available as of this morning. Stacks represents a powerful evolution in provisioning that directly addresses the challenge of managing these interdependent configurations at scale. It allows you to break down your infrastructure into these logical components: networking, databases, your computing platform, and then deploy these as cohesive, repeatable environments, all driven by your existing VCS workflow. So a question you're probably asking, all right, when do I use Stacks instead of the workspaces I'm already using? It's a pretty critical question. Think of it this way. Workspaces are for managing components: your VPC, your database, your Kubernetes cluster. And each is a perfect use case for this workspace. They are the individual foundational building blocks. Stacks are for managing systems. You should use a stack if you plan to deploy your configuration more than one time, like across dev, staging, and production environments. The tipping point? That's when you start spending more time wiring your workspaces together, manually orchestrating run triggers, sharing outputs with complex data sources. Heard a little bit about that from some of you yesterday. Then you do actually building it. Building anything, I should say. That's your signal. That's when you know it's time to move from managing components to orchestrating systems with Stacks. So let's take a closer look at what this means in practice. Stacks gives you three powerful new capabilities. First, you have coordinated deployments with deployment group orchestration. Second, it provides advanced dependency management through features like deferred changes and linked stacks. And finally, it's all built on a VCS-driven architecture, which means that every part of your stack is managed as code. And this is all designed to fit into the complex, secure environments that real enterprises operate in. So the stack we're about to see is connected to our VCS. And with the GA release, this could be GitHub, GitLab, Azure DevOps, or Bitbucket. It could just as easily be running on our own self-hosted agents in a private network, too. This also creates a better developer experience. With a unified CLI, you can give your developers the ability to author and test stacks locally without needing to commit every change, which makes their iteration loop so much faster. This is about how we map the path forward. So let's see what that journey looks like in action. So to give you a real-world example of what this unlocks, let's look at deferred changes. For anyone who's worked with complex, interdependent resources like Kubernetes, you know the pain of a plan failing because a value isn't known yet. Stacks solves this because it can now produce a partial plan and automatically continue with those values when those values become known, turning a major point of friction into a seamless, automated flow. So in the demo we're about to see, we'll show a full Stacks workflow, and I want you to pay close attention when we start to get ready to deploy, and instead of things failing, something else happens. You'll see exactly how deferred changes turns into what would have been a failed plan into a successful deployment. Oops, I got so busy, I forgot to show you these things. But I think you get it. All right, so we're in our ACP Terraform workflow now. And we're sorting a bit in medias res here with our deployment already active, because we've already pushed to get at this point. And up above, you can see that publish output block, and we'll talk about that when we get to link stacks in a second. But I want to show you the auto approval rule that we've defined around safe developmental plans. As long as there's no destruction or changes, we automatically approve that plan and move forward. And we'll see our add-ons, EKS Fargate, our VPC, our application, all on the left side. and that auto approval, as I mentioned already. And that link stack for the VPC ID a little later. So again, our VPC is already up and running, and we're waiting ever so patiently for our EKS cluster to come up. But you'll notice that we have several options here, the HashiBank, add-ons, namespace, RBAC, that instead of failing, they're just waiting for their time. We can also see our auto approval orchestrated by the rule that we said earlier. This is the link stack side. So like if you have something like a downstream stack for, say, our application security team needs to have access to our cluster via security group to do a bunch of scanning and all that other stuff, we can actually go ahead and implement that really easily. As I spill water on myself. I'm a professional. So now we have so much new that we can talk about now. We can actually deploy an entire multi-component, in this case, HashiBank application to Kubernetes in a single unified run. So now our plan and our apply is wrapping up here. And we'll see in a few minutes, a minute or two, I should say, that our plan will begin again. And since we already approved it, we actually will already proceed to the apply and start to build out the other components of our stack. Because in the old world of workspaces, everything would fall apart right about here. The Kubernetes components can't be configured until the EKS cluster exists, right? But since we have that initial deference of our add-ons, our RBAC components, Stacks understands that dependency, and instead of failing, as I mentioned earlier, it just waits. A bit ahead of myself. There we go, as we skip ahead here. And now we can see now the EKS cluster is done, and we'll scroll down here in a minute. You'll see that as the add-ons begin to spin up, and the seasonings, as I said earlier, as I said before, I should say. And we also see that the apply finished as we wrapped up earlier, the plan automatically queued and started already, as we can see there. And this will continue as long as we need it to until we have a fresh deployment of everything that we need. So, as you saw Armand announce a little earlier, Terraform Search is now in public beta. And it's highlighted in the keynote, now that you can manage all these complex workloads with stacks, there's still the problem of how you discover them to bring them under management. This is especially true for those of us who didn't have the luxury of starting with ISC from day one. That's where the new tfquery.acl file comes in. It lets you declaratively ask Terraform to list resources with specific filters, like all running instances that aren't tagged as being managed. The Terraform query command then takes that file and can automatically generate the configuration that you need to bring that unknown territory under control. It's like actually playing a game of Risk and actually finishing it for the first time instead of flipping a table. I don't know that from experience or anything. So this is a critical step for any platform team. You have to define the unknowns to bring them under management. And once you have, you can start defining those golden paths for your developers with self-service workflows, which is exactly what Bharath and Tajitha are going to show us a little later this afternoon, actually right after this. And for those who want the full technical deep dive for Terraform Search, Cole and Garvita will have a session about that tomorrow that you don't want to miss too. So how do we keep this journey safe and compliant? By providing the guardrails for the path. In our story, that mentor is governance. And I know, boo, governance, pitchforks, torches. But the goal isn't to slow developers down. It's to give them a safe, automated path to production. We do this by solving the blank page problem. Instead of writing policy from scratch, we provide a library of wisdom with over 350 plus, I believe, at this point, pre-written Sentinel policies for AWS. And don't worry, Azure and Google Cloud folks, you are on the roadmap and coming soon, so let us know what you need. This is covering key standards like CIS and financial services benchmarks. I believe NIST just came out today. Again, not about blocking the path, but about giving your teams a map so they don't have to draw their own. This turns policy from a gatekeeper into a helpful guide for the entire journey. So, after we've given our hero these new tools, stacks, search, guidance around policies, the journey begins to change. The path is no longer dark and full of terrors. The experience of the developer, our original hero really, is transformed. They begin saying things like this: I get it now. I'm not afraid of this platform. I actually want to use it. That was weirdly helpful. And suddenly, that profound shift happens from friction to flow, from confusion to clarity. They're no longer just surviving the platform, they're empowered by it. So what we're really talking about today is a modern hero's journey for every platform team. We all started at the same place, a world of chaos and unknown infrastructure that was created outside of our process. That's our call to adventure. The tools we've looked at, like Terraform Search, for example, are what allow us to cross that threshold. They're the map and compass that help us define the unknown territory. And from here, the journey continues. You take what you've discovered, begin building those standardized self-service workflows, like those golden paths we talked about. And then ultimately, you return home, back to the Shire, a better place, a fully managed, auditable estate. I know, that can feel like a pipe dream. It really can. But here's a secret. Some of you in this room, and some of you watching this online, you know this to be true. You already know this is possible. It's a continuous cycle, and it all starts with taking that first step to chart the unknown. There it is. So this is where the work really, really is. Not about selling a product, no matter what it is. It's about creating belief. It's the belief from the developer that the platform has their back, the belief from leadership that costs are managed, and the belief from security that risks are mitigated. Because without belief, there's no adoption. Without clarity, there's no sustained progress. And without a compelling narrative, there's no trust. We've been having this conversation about IAC for years, and yet so many engineers still feel stuck. Infrastructure only gets noticed when it fails. That's our branding problem as platform teams. But when we make the journey clear, when we tell that story of guidance and partnership, that platform transforms from an opaque gatekeeper into a trusted partner, not a black box. This narrative clarity connects strategy to implementation. This is how narrative clarity helps the business too. When developers understand what to do and why it matters, things move faster. Not just because the tech works, but because the humans believe in it. You might be the only one in your org that's thinking this way right now. And that's okay. After all, the hero is often alone at the start, but that's where the greatest impact begins. Every movement in history starts with someone who steps outside of the norm, and you're that someone. So, what are the key lessons from our journey here today? First, to relentlessly pursue clarity over complexity, because clarity is what reduces the cognitive load and the chaos that leads to things like burnout. Second, frame governance as a mentor, providing a safe, predictable path that doesn't require a hero to save the day. Third, and really importantly, most importantly, remember that our job is to build platforms that tell better stories. Platforms that replace last-minute heroics with calm, sustainable systems. And finally, a little homework for you. Start your next chapter. Go back to your team. Find one point of friction. Take that first step on the path to building that better system. Because the hero's journey isn't about one person saving the day. It's about building a world where they don't have to. Thank you all so much for coming on this journey with me today. especially since this is my first HashiConf. I'll be putting the slides up on speaker deck here in a few minutes. You can find me on socials if you want to connect, LinkedIn, wherever. I'm an extrovert. I love talking about this stuff, so feel free to find me. Don't be a stranger. I'll be at the booth later this afternoon if you want to hang out. Been a pleasure taking you there and back again. Peace out.
Nice work, man.
Oh yeah, you need this.
Yeah, I want to give a big thank you to Jacob. Great talk. It was really great getting Terraform stacks out the door, and now we can actually see it and play with it, which I think is really cool. You know, I kind of felt seen when he was talking just now because I used to be a system engineer. We tried to replicate environments with a collection of duct tape and bubble gum and all these other things, and it didn't go well. So it was really nice. I wish we had kind of stacks back then. But let's not focus on the past. We're here for the present, right? Now, please hit up the QR code. This is a way for us to know about your session feedback and what you think about the talks. This is really great for us to be able to know what you're interested in, how we can make changes, okay? Now, we're going to take a short break. When we come back, now, if you do leave the room, please hand off your headphones back to the production staff. What they're going to do is take your headphones, sanitize them, and then give them back for people that come back, all right? Now, when you come back, we're going to have Bharath and Tajita of HashiCorp. They're going to talk about how you can take your Terraform and it can be a setup for the foundation for your IDP and extend it to empower your developers. All right? See you soon. Hello, hello. Even for the people in the back. All right. Hello and welcome to Cloud Engineering Track number 1. Cloud Engineering Track number 1. To speak about how Terraform setup can be more than infrastructure as code, it can actually be a foundation for your developer self-service experience. Please welcome HashiCorp's Bharath Ramanathan and Tajita Raju.
Thank you.
All right, let's start with a quick reality check. According to the latest 2025 developer survey conducted by Stack Overflow, developers report being blocked, not by their own skills, but by delays in access, broken environments, delays in provisioning, or endlessly chasing approvals. This is the kind of friction that they face week after week in their workflows. And these are costs that typically don't show up in budgets, but one every developer feels. But also the kind of pain points we are talking about are the ones that are leading to transformation in the way organizations work. According to Gartner, by 2028, 85% of the organizations that have platform engineering teams are going to expose services to developers through internal developer portals.
The good news is that you already have the foundation for it. It's your existing Terraform setup. The primitives that you're building on top of, like providers, modules, no-code modules, are going to be the building blocks of building an entire self-service platform by itself. Today, we're going to walk you through how you can extend your existing Terraform and empower your developers while keeping governance intact.
Absolutely. You forgot our clicker.
Sorry. Yeah, you can click it.
So to introduce ourselves, so my name is Bharatram Ramanathan, and I'm an engineer turned seller turned marketer, and I live in San Diego, California. And a couple of fun facts about me are, one, I'm big into pickleball, like so much so that I carry a couple of paddles everywhere I go, right? So if somebody is into pickleball and want to take me for an open play this night, absolutely up for it. Two, I'm also big into frozen yogurt. Like if not speaking here, you might spot me in one of the froyo bars around the city. Take a cup, pick the flavor, pull the handle, and put my toppings. And nothing beats that level of self-service that I like.
Yeah, interesting. Let me go along the same lines as well. I'm Tejita Raju. I, very similar to Bharat, started off as an engineer, transitioned to product. More recently, my biggest focus has been to make sure developers have a much easier self-service experience. So obviously focusing more on simplifying that. Let me see, what is, oh, I love my espresso machine, right? It's a morning ritual. I wake up in the morning, make a shot or a double shot of espresso. Ooh, my steam wand where I can do whatever and like grind. Obviously, a lot of options. That's a whole separate conversation or a whole separate talk. Interestingly, if you look at the froyo and the frozen yogurt and the espresso, we kind of get that self-service experience,
Absolutely.
Right? What would it look like if that kind of self-service experience was not available to developers in organizations?
You asked a great question there, Tej, right? So what happens when developers don't have self-service? Here's what happens. Companies end up with ghost teams. Mm-hmm. Since it's almost Halloween, let's actually talk about ghosts. Every company has one. You won't see them in the org chart. You won't see them in the budgets. But you have your ghost teams, AKA the developers that wait endlessly for approvals or for environments. So these are the kind of friction that developers face week after week, as the Stack Overflow survey talked about. Let's do the math here, right? So let's take a mid-sized organization with around 800 developers with platform and security teams supporting the developers, if you take roughly a couple of hours a week per developer of idle time, it quickly adds up to thousands of hours of developer productivity lost. Add on top of that, your platform engineers and the security engineers trying to support the developers, it leads to several thousands of hours of engineering productivity lost, which is the equivalent of 2 or 3 full capacity engineering teams that exist but just don't deliver. Now this waiting cost, right, the hidden cost of waiting isn't random. It actually comes from how organizations typically work today. What I call as the producer, consumer, and the approver triad. On one hand, you have the producers who are the platform engineers that are drowning in tickets, are building the same infrastructure over and over again and again. On the other hand, you have the consumers who are the developers that are endlessly waiting for environments or approvals. But right in the middle are the approvers or the security and compliance people that are babysitting approvals or rubber stamping requests, and often seen as the people that delay everything in the pipeline. According to the HashiCorp Cloud Complexity Report that we just released, if you haven't read it, totally recommend it. Amongst the 1,100 respondents that responded to the survey, 73% of them say their developers, platform engineers, and security engineers don't work in unison.
Yeah, honestly, we've talked to a lot of customers where nobody's happy in this situation. Engineers feel like, the platform engineers feel like they're constantly getting orders, and on the other side, developers are constantly frustrated and blocked because they're not getting what they want. And irrespective of how your organization is structured, there are this compliance or approvers that kind of feel like they're bottlenecks overall. From a product perspective, it just looks like a complete ticketing black hole than like any usable product.
Sure, totally agree there. So we have seen the triad is now broken, right? So how do we fix it? The good news is you don't have to start from the scratch. You already have Terraform, the foundation for your infrastructure already today. Terraform is consistent, it's codified, and it's repeatable, right? Which already are huge steps in the right direction. But Terraform by itself doesn't deliver developer self-service, right? You need additional layers on top of Terraform to deliver end-to-end developer self-service.
Of course, so the additional layers look something like this, right? So we have guardrails where we define and enforce policy as code and compliance baked in, so engineers can move faster while also staying on the lanes, on their own lane. Governance by itself, making sure your approvals, auditability, and cost controls are in place so that infrastructure obviously is like easy to use, but at the same time more accountable. And finally, we have the workflows itself, basically how developers are consuming the infrastructure that you were providing, be it Backstage, ServiceNow, Waypoint, or God forbid, even GitHub Actions. We just want to make sure it's absolutely easy for a developer to have an idea and start running the application in a much more accelerated way.
Absolutely, right? So this is where the magic happens, where you have Terraform being the foundation for your developer self-service.
Yeah, we want to use those guardrails so you can take your existing simplified, even though I'm oversimplifying it, infrastructure as code to the next level as a self-service platform overall.
Absolutely. So when we talk about self-service, right, it's easy for me to stand here and lecture to you saying, hey, like drop everything you do today and buy X and Y to have self-service. But that's not how engineering organizations work. That's not how real progress is made. Every platform, tool, workflow, or process that you're using today, it didn't land by accident, right? You had individuals or teams doing due diligence to validate it, doing POC, and then you embraced that decision. So it's very unfair for me if I were to say, hey, like drop everything and buy this X and Y. What I've also seen work is, or what I've seen work is the concept of meeting teams where they are in their tools, in their products, in their workflows, right? And you all have a fantastic foundation in Terraform. And self-service itself there is no one path to self-service, right? Some organizations may use developer portals like Backstage or other commercial developer portals for achieving self-service. Or some organizations are deep into ticketing systems like ServiceNow or Jira, right? And they might be using self-service in their own ways. Or some teams may demand that self-service stay within the Terraform construct, right? Irrespective of which path you're going to take, Terraform remains that foundation that's tying all of those self-service together. Whether it's developers clicking on portals, or submitting tickets through ITSM-based workflows, or staying within Terraform, we are ready to show you how you can achieve self-service by extending Terraform from where you are today. So with that, enough talking. We want to shift to demos and show you multiple paths, what we demonstrated here in terms of a flowchart in real action. The first path we are going to talk about here is developer portals. When I say developer portals, one of the names that is synonymous with the developer portals is Backstage. It's a household name, right? We have talked to a lot of customers, and customers love Backstage because it's open source, and it's very flexible. You can do whatever you want with it. But also, we have heard on the other side, customers complain saying, hey, like using Backstage is like shopping at IKEA. You buy a big box, millions of parts, and it takes endless time to assemble it. On the other side of the spectrum, you have commercial developer portals. One of the examples being Red Hat Developer Hub, right, which is built on top of Backstage, but it's batteries included. Or there may be other developer portals, right, which are also available in the market. The point is to say not one is better than the other. Each one's journey is different, as I said. And depending on how much you want to build versus buy, again, it's going to be different. So in this example, we are going to show how Terraform acts as that orchestration layer, taking a developer portal to a full-fledged self-service platform. And Tej would talk us through the demo here.
Yeah, let's do it. Let's actually discuss about why this kind of makes sense, right? So we have organizations where developers are going through a multitude of tools, and the ask from platform engineers is pretty simple. I don't want them to go through all these tools. Can you give me a solution that's exactly one portal by itself? That way, it's much more easier for developer to get started. So let's actually jump in and look at an example where an AI engineer is wanting some resources, and we will provision it with Terraform. So we are actually, the example by itself goes through, oh, sorry, I should play it. Goes through identifying the provider we want to use. Think about creating some machine pools. Machine pools are a group of EC2 instances. So I'm looking at the provider as a platform engineer, looking at the provider in my private registry, making sure that I know all the inputs and outputs necessary to set it up with the developer hub by itself, and making sure everything is ready. Let's actually switch back to the view with the developer itself. So this is Red Hat Developer Hub. So obviously, we're only going to look at self-service today. I, as a developer, am focusing more on cluster automation. Almost everything here runs Terraform behind the scenes, but we're going to focus more on creating that machine pool. So what this template does is creates a machine pool on an existing ROSA cluster. And ROSA stands for Red Hat OpenShift, specifically on AWS. So I'm going in, providing my inputs. I'm choosing a cluster name. Obviously, a machine pool name, I'm choosing the instance type. I'm choosing an ARM node, so my machine pool name is also an ARM node. I'm enabling auto-scaling and making sure I give the minimum and maximum replicas. OK, everything looks good, and I create. So now you can see the progress of what's happening with respect to the Terraform run by itself. I can switch back to Terraform Cloud and look at the plan being applied. Within Developer Hub, I get notified as soon as the machine pool gets created on AWS. You can see how things have been very simple. Developers don't have to leave the platform by itself, and everything is readily available. The good thing about Developer Hub is it's not just about bringing Terraform. You can connect absolutely anything to it. So think about developers wanting VCS, bring it to Developer Hub. Developers wanting like Jira, bring it to Developer Hub. It's going to be one singular portal where developers can pick and choose everything that they need. Did I? Sorry.
All right. So that was a very neat demo, right? Like where a developer expanded their machine pools on Red Hat OpenShift on AWS, right? Very easy, or looked very easy, because Terraform was the orchestrator that was actually doing everything behind the scenes. And one of the key things that Terraform brought to the table was taking the concept of a developer portal and extending it to a full-fledged developer self-service platform, right? So that's what HCP Terraform in that instance did. And developers got the speed and simplicity without learning to use Terraform or learning HCL. Platform teams remained in control and keeping governance intact, and which results in faster, consistent, and scalable delivery if the teams standardized on developer portals, as Tej showed an example being Developer Hub, but can be any flavor of Backstage or any commercial product that can integrate with Terraform through APIs. Now that we have seen that, let's shift lanes to the next path that we had in the flowchart here. We're shifting to enterprise lane, where one of the examples that we want to demonstrate is a ticketing system, right, like ServiceNow, where it's seen as the system of record for governance and compliance. It's the front door for IT, where all of the requests, approvals, and incidents live. And the key thing Terraform brings to the table is one of the key things that the ITSM applications don't have is a sophisticated orchestration or automation system on the back end, which is exactly what Terraform brings to the table, taking the ticketing system to a whole new level of developer self-service experience. And again, switching back to Tej to demonstrate that.
Yeah, let's quickly talk about why this makes sense, right? So we always find it hard when we're pitching self-service as a concept to organizations, especially when they're in highly regulated environments, because the governance and the approvals cannot be completely removed. So self-service kind of needs to run in parallel with the guardrails that they've already set in place. So ServiceNow is a natural partner here for us. And let's actually go through a very good example of how it's helping some of the organizations today. So this is our, sorry, I have to play again. This is our, did I play? Should I play here?
Oh, yeah, there you go.
OK, so we're going to a Terraform catalog. We're choosing our catalog items. Think about catalog item as a template itself. I'm providing some variables. So basically, what I'm trying to do is create an RDS resource. I give them a workspace name, and I provision the workspace by itself. But obviously, we can go and see how things are working on the Terraform side. But the good thing about ServiceNow as it is it doesn't stop there. It also goes to day 2 ops of things. So if, say, I decide to make a change to the existing resource or just the infrastructure itself, let's actually go to the module, and I decided to add a load balancer. So I basically commit the changes. I'll go through the basic VCS process. I cut a new release. And obviously, that's what's happening. And Once that is done, it doesn't stop there. I think sometimes we hear this a lot. You have to make sure you go to your registry and you pin the right version. If it's your latest version, you should do that so that anything that's pulling the no-code module itself, make sure it's using the version that is intended. So now when I go back to ServiceNow, I can update the existing workspace. So I just give the workspace name. I get updated, and it goes back to the existing workspace, and we can see that the load balancer gets added to the existing workspace. Come here. Let's actually, while this is going on, let's actually also look at how things look like from the developer perspective, right? So this is how a developer gets started. So until now, we saw how platform engineer sets everything up. Obviously, we try to speed up a few things, but the process is pretty much the same. So the catalog item exists. The developer can go in and provide some input variables, and then things get started behind the scenes. You can see how the no-code module by itself provides that a much stronger ecosystem for ServiceNow.
Awesome. That was a very neat demo of how developers can still attain self-service within the construct of IT self-service management systems, right? Where the governance, the audit trails, and the controls remain intact, and Terraform powers automation, consistency, and visibility to the whole teams. So this actually sort of wraps up the path 2 that we wanted to show you. And the third path we wanted to show you is where teams are huge in Terraform, right? So they want to stay within the construct of Terraform and expose developer self-service to teams from within Terraform, and which is where HCP Waypoint comes in. HCP Waypoint is a Terraform native developer self-service that standardizes and abstracts away infrastructure from developers. And it comes in with a very neat, simple GUI or API access for developers. And the platform teams maintain the guardrails that they need and stay in control with security also weaved in. So let's see the last demo here. Tej being the product manager for Waypoint. She's going to be super passionate about it, and we're going to take it home with this.
Yes, yes. Obviously, my favorite. I don't want to repeat the same thing. So yes, the ask from the developers is pretty same. They want to be able to get started. They want to be able to have a single central place to get started. But the ask for Waypoint by itself is more about from the platform engineers. So they have their existing infrastructure already in Terraform. They've heavily invested in Terraform. They don't want to worry about new products, new tools, setting everything up. They want to get started as quickly as possible and provide value to their developers. Let's actually go through an example of Waypoint by itself. So here, Waypoint also uses no-code modules as a starting point. So this example goes through using a no-code module to create a template that is going to deploy an ECS cluster. So here's a template. When you create a template, you get to see all the developer instructions, the inputs and outputs. Some of the inputs are already defined by your platform engineer, but you as a developer can provide some inputs if it's requested by your platform engineer. You can see that this template by itself has no action associated to it. Once that template is provisioned, this is how it would look like as an application. And obviously, the application has its own inputs and outputs. So now let's go and pick an action and associate it to an application. This is what a platform engineer would do, provide the ability to do one-click actions on top of the existing applications. So I'm going and applying these changes, and my existing application, action is associated with an existing application. Let's actually go to the app. I'm quickly showing you a private repository for that, that we will be using. But let's switch back to the action itself, the application itself. Within the application, once I go in as a developer, I have an action tab, and obviously I have an action that deploys to ECR. So what it does is, I as a developer have an application. Think about it as simple as a to-do application that I'm packaging and deploying to ECR. This is going to take a few minutes, but let's actually wait and see if the image shows up in the registry by itself. Once that is done, we go back to the ECS that we already deployed and make sure it pulls the latest version of it. Now you can see the task is running. So we'll switch back to our application, pick the URL endpoint, and voila, we have the to-do application.
There you go.
So just a quick recap of the demo itself. So it's absolutely easy for developer to get started because your infrastructure already lives in Terraform. And we leverage primitives that I told you that creates both golden patterns and golden workflows that take you from day 0 to day 2+. The overall takeaway is it's much more simpler Terraform native way to get started with self-service without you having to figure out new tools, new services, new integrations. So it's absolutely easy to get started. Over to Bharat.
All right. So when we started this session, we started talking about the reality of the status quo, the pain points developer face, the ghost teams hiding within the organizations, and the producer, consumer, and the approver triad, which wasn't working. And we also saw the answer wasn't in ripping and replacing tools, platforms, and processes, rather extending the foundation that you already have, Terraform. We showed you through the demos that self-service is possible through multiple paths, as there is no one standard way to achieving self-service. It can be through developer portals, it can be through IT service management applications, or from the construct of Terraform itself. Different paths, different entry points, but the same outcome, being standardized self-service without sacrificing guardrails and governance.
But overall, this is the synergy that we want, right? So producers get the governance built in. And on the other side, consumers get self-service. And the approvers get everything, guardrails. They're not being bottlenecks. They're providing the ability to get started as quickly as possible. And Terraform overall delivers this alignment across team without compromise.
Absolutely. And all of these benefits are not only qualitative, right? So there are serious quantitative benefits to achieving self-service using Terraform. Like we saw, there were several thousands of hours that were wasted because of developer and engineering wait times, right? With ghost teams, and we all talked about it.
Yeah, but it's not like the hours are going away. It's just they just come back as features shipped, value delivered, developers moving faster. So it's going to take minutes to get started for your developers instead of days, and the overall toil is reduced.
Absolutely. Reclaim almost all of those several thousands of hours. It's like getting, again, as I said, 2 or 3 full capacity engineering teams without hiring a single headcount. Think about it. Think about all the bonuses you would unlock if you were to deliver that, right? To take us home, right? Terraform is already the standard for your infrastructure today. And it can be, through the demos and the talk track that we talked about today, the standard for your self-service as well. The shape it's going to take, it depends on your tools, your platforms, your workflows. But rest assured, we are here to meet you where you are and take you along every step along the way.
Yeah, one of Bharat's and my important job is to always listen. So if you're ever passing by, please stop us. We would love to know where you are, what's working, what's not working, where you're seeing the friction. It'll give us all that information so we can take and build it and build a better product that works for you. Thank you so much.
Thank you. Thank you, and have a great rest of the HashiConf. Thank you.
Nice work. Nice job. Just want to say thank you for Bharath and Tajita for their talk. One little small note, actually something about that they just mentioned is when I was a system engineer, we had dreams of having our own IDP, but it never succeeded. And so it's really nice to see how they can be realized through the tools they talked about today. Now we're going to take a quick break, but before we do that, please hit up our session survey. This is a way we can let you know, you give us feedback about the talk, let us know how we make changes. All right? So quick break. When we come back, we're going to hear from World Bank, and they're going to talk about how their success story and using Terraform to accelerate their cloud transformation with Sneer. All right? Also, as you leave, please hand in your headphones so they can sanitize them. You'll get them back on your way back in. All right, thanks everyone. Take care. Hello, everyone. Hello, hello. Yes, yes, yes. Welcome back. Welcome back. Now, next up, to talk about how using Terraform can accelerate cloud transformation, we have Sunir. Take care. Thank you, Trevor.
Okay. Good morning, everyone. Okay, let's begin. Does the clicker work? Okay. A quick show of hands. How many of you have thought you would give your developers an easy button so that they can just press and then get their infrastructure and platform they need, and they can start building right away, and they stop bothering you? Okay, cool. This session is for you. What if such easy button can be built and platform delivery can in fact happen in minutes? This is not hypothetical. This is what we have built within World Bank using Terraform. So we're going to talk about that all today. By the way, my name is Sunir. I'm a platform engineer at World Bank. And I started my career 18 years ago as a full-stack developer building enterprise applications. And I caught a big data wave, did some data projects for financial institutions and stuff. I moved on building machine learning and fiddled with the BERT when it was released by Google. And then I decided, you know what? I'll start building infrastructure. And then ChatGPT was dropped. All right. So because of that, I brought a lot of challenges and pain into my dear infrastructure team so that I can solve those. So the first challenge we set out to solve was there were a lot of manual processes. So there's a lot of click ops, a lot of ticket ops. Everything was configured manually, and it's in multiple different subscription, multiple different AWS account. You get it. So if there is a manual process, you leave fingerprints. You leave a lot of fingerprints that you have to manage forever. So what does it lead to? It leads to configuration drift. You have inconsistent dev environment. Dev is nothing like production, and you are in an inconsistent mess. And it brings us to a compliance challenge. We live in a very dangerous world. Cyber threat is emerging every day. Cloud vendors are improving their products every day. And everybody's catching up. And on top of that, how do you keep up with the compliance challenge that you have at hand? And because of all of that, what you end up happening is that you treat every app as a special app, because every app needs a special care. If a data team comes to you for a data platform, if an app team comes to you for an application hosting platform, you take their requirement, sit with them, design specifically handcrafted platform for them. And you do this hundreds and thousands of times. Now you have all handcrafted platforms running your real estate that you have to manage as platform team. This increases cognitive load, not just for platform team, also for developers, data engineers, data scientists. All of them have to deal with this complex setup. And we have our new CIO join, and she put forward a very transformative digital transformation strategy. As part of that, we did an internal study. We call it Developer Experience Catalyst Team. As part of the study, we published a white paper that kind of outlined all of this in a formal way. And we set out to solve that problem. So how do you solve the problem? We need to bring a good, strong platform engineering strategy. So it has 4 pillars. The first one, of course, is developer experience. We give our developers internal developer portal and enable them to have a self-service capability, and defined golden path for apps, data, and AI applications, and built scorecards and created a constant feedback loop so that we improve them in a constant basis. Second focus is security by design. We don't want our policies to be sitting in a Word document. If there is a security policy, it has to be converted as a code so that you can version them, you can audit them, and you can enforce them. And we need to have strong secret management strategy, security scorecards. Thirdly, we have defined uniform platform standards across the board. This is where Terraform modules comes into play. We built reusable, composable Terraform modules and published them in our internal private registry as part of HashiCorp cloud platform. And whenever you have a standard, what do you need? Standard change. You need a standard governance. If something were to change, it has to be through code, having a proper PR process so that those standards can be changed and applied in a version manner. Third, without AI, this is not a tech talk, right? So we have to embed AI in your workflow. We gave all our developers coding assistants and AI-assisted policy checks and have a strategy to have AI-generated test cases, intelligent observability, AI ops, and automated documentation. Automated documentation is not just for humans anymore, right? You have all the prompt libraries that you need to keep up because you have to guide your vibe coders very well. And now that we have a strategy, how do you translate this into something that an IAC development team, a platform engineering team can consume? That's where the platform engineering framework come in. It's almost like a pyramid. At the very bottom, we have modules. These are hardened Terraform modules. You take a cloud service, you infuse your best practices, security standards, and all the security controls that you have had over the years, and convert them as a code and publish them as Terraform modules. And on top of that, you build a higher order product called Terraform templates. This is nothing like a super module. You stitch this module together. That is something that is consumable. For example, a Azure Kubernetes cluster. If you provision an Azure Kubernetes cluster by itself, it's not consumable for developers. You need an ingress controller. You need to have app gateway on the front, and it should have a secret management, key vault or hashi vault, have a CSI driver connected to it. All of this module come together, then it becomes a consumable product a developer can consume. So now that you have a templatized product that your developers can consume, can they? No. They need a workflow. They need a secure, consistent workflow so that they can deploy these templates in a production environment or in a dev environment in a secure, consistent way. That's where the platform provisioning workflow come in for day 1 and day 2 activities. On top of that, we saw a pattern emerge. Most of the time, these Terraform templates are requested together. You need a compute, you need a key management system, you need an observability template, you need a database template, and then there are other patterns that I saw emerge. So this is where we defined our platform as a product, golden path for data, app, and AI platforms. So we have only 3 products. At the top, how would you sell this product? What is your storefront, right? Our storefront is our internal developer portal that we give it to our developers. It is a web interface today. The word portal is a bit misleading. It should be internal developer interface because it can be a CLI, it can be an API, it can be an MCP server. Your agent would call and then get things done, right? So that's what we envision as a platform engineering framework, and this is what we put it to use. How does the self-service workflow looks like? Now that you have the modules, templates, golden path, and the IDP, how does the flow looks like? It's pretty simple. A developer would request for a golden path product in IDP, and it would trigger a platform management pipeline that would deploy these Terraform cloud workspaces, pre-fill all the variables, connect to the agent that's going to execute this, and then configure the Git repository that has all your golden path well defined. And that's where the platform developers operate. They operate at that Git repo. And then once your Terraform cloud does plan to execute and deploy these golden path patterns, what happens? You want to embed security as into the flow, not as an afterthought. So when Terraform plan execution is done, we send this plan via a run task integration to our security scanning tool so that the security scan can happen right at the gate, and then our infrastructure can be deployed in compliance, if it is in compliance with the security standards that we set. And then it would also run a policy as code enforcement. So if everything looks good, it gets deployed in our hybrid cloud environment, Azure, AWS, and on-prem, and GCP. So this is the workflow we talked about, and let's focus on an architectural view. How does, for an architect's eye, how does it look like? At the very bottom, we have a resource plane where we consume services from Azure, AWS, and GCP, a wide spectrum of technologies, compute, network, services, data. It could be a Kubernetes cluster, or it could be a VM, it could be a firewall configuration, it could be a storage, whatnot. This is where we stop reinventing the wheel. We use these services out of the box, and then we operate at the next layer, which is a platform plane. This is where we build our product internally. We extensively use Terraform and Sybil and Arco CD, Terraform in a very big way. And then we have a platform delivery pipelines. This is what deliver our golden path patterns. It's use Terraform, Ansible, and Argo CD in combination and deliver this platform as a service. So once you have this service available as an API or CLI interface, you want to give developers an experience that they are so used to. In the developer plane, you have developers, data engineers, and data scientists operate. They use their own set of tools. You want to integrate your services through MCP using GitHub Copilot and a developer portal, which is a web interface that developers could actually consume these services right off the bat. So this is what an architect's vantage point looks like. So we talked about all of these architectural constructs and the workflows and all of that. What are our platform products? We have two platform products, application platform and data platform. We keep it simple. This is what we're going to talk about today. This is what my lead usually says. He's in the audience. Keeping things simpler is the hardest job, right? So you have to keep things simpler for our developers, right? So what is an application platform looks like? For any application, a full stack application to be deployed, most of the apps that we deploy are internally facing. So it needs to have a VNet and all the network security controls. And then you probably have user interface, an API, a database, and we standardize on our tech stack. It's not a top-down standardization. We looked at our real estate, what is the most used technology, Node.js, Java, and .NET. So we want to be able to give a platform that can host these kind of technologies for both user interfaces and for APIs as well, the same tech stack. And we want to give our developers option to choose multiple databases. We don't want to enforce them to use only this particular database. We want to give them choices. We gave them Postgre, MS SQL, and Cosmos DB as a NoSQL database because we deployed this golden path in Azure. It will be applicable in other cloud vendor products as well. And then we saw our developers use serverless functions like Lambda and whatnot, and Azure Function whatnot. So we give that as a capability that you can add it into the application platform. And then developers have a high-performance applications. They need caching, right? So we standardize on our Redis cache and make it as part and parcel of our template, build a Redis cache module, standardize it, infuse our security controls, make it as part of our template. And then you will have use cases where you want to store videos and files and deal with object storage. So we added object storage as a capability into our application platform. And all of this component should have security into it. So it should have authentication enabled. It should have native authentication wherever possible. We use managed identity for the most part. And as you can see, not all dev team needs everything, right? So if there was a development team who just needs an API and database, they don't care about the serverless and cache, you give them option to actually toggle switch. You can enable and disable. So once you get a slice of this architecture, developers going to the dev portal, they can turn off their cache, turn on later as a day 2 activity. it happens most of the time because it starts small with a UI API database stack, and then they get a lot of adoption. They might add a cache, and they might add object storage later. So it's not like they have to call in a platform engineer, set up a meeting, and all of that. They just go to dev portal and then enable that, and then they get the cache they want, which has all the security controls and best practices baked in. Now, we have a lot of standard components like monitoring, logging, key management, DNS, managed identity. This comes standard as part of the architecture that we deliver. So this is not an option. Think of it as if you're buying a car, you don't get to choose whether to have an airbag or whether to have a seatbelt or not. It comes standard. This is part of the security, and it's not something developers have to worry about. It's always there. So that is application platform. Let's talk about data platform. So data platform, if you look at it, you have compute, and you have storage needs, and you have AI needs. On the compute side, we have analytical platform, like large compute clusters, like Databricks, AWS EMR, and there is a data movement system, data integration platforms, where you need Data Factory or AWS Glue. These are the common pattern that we have seen. And it needs to be protected with the private endpoint and stuff. And it should have a key management. Whenever you have a data system, it needs to connect to database. You should have a strong key management system. On the storage side, we give capability to have a data lake, relational database, NoSQL database as an option. In the AI, obviously, if you're doing a retrieval augmented generation, you need a vector database, and you need to give them ability to enable LLM APIs, be it Azure OpenAI or cloud or whatnot. So we're not in the business of building LLMs, but we make them available as a model garden within the data platform. Then, the most important part, this whole thing has to be integrated with a private endpoint or private link, whichever cloud vendor that you use. And the same applies. Not everyone needs everything. So there would be a data team or data science team who just focus on a data analytical platform and they just have a data lake. Or there will be a new team whose main concern is the LLM APIs and vector databases. So they can turn off and turn on based on the slice of the golden path pattern that gets deployed. So we talked about developers and our clients' use case, developers, data engineers, and data scientists' use cases. What about us? What about platform engineers? What their life looks like at day 2? So the Terraform code resides in a Git repo, obviously. We have templatized all of that. So if you want to make a structural change, if there is a security vulnerability that was found in one of the cloud vendors' product, and you have to change a Terraform code or Terraform module and release a new module of it. So you make the change, do a PR merge, or Terraform Cloud Workspaces are connected with a VCS connection, and it is managing a fleet of infrastructure, not as one singular instances. So if you make a change, the Terraform Cloud will run the plan. If security checks are passed, policy as a code is enforced. If everything looks good, it goes to the entire fleet. You can stage it, of course. You can do dev fleet first and QA next and production. So you have the ability to manage a large swath of infrastructure in a structured manner. So what were the key results? We have increased our speed of delivery from 5 days to 30 minutes. And 30 minutes is just execution time, right? And we have increased our standard adoption. We reduced our unique apps count significantly because we have built this optionality within our golden path, so everybody consume our services, so that it naturally increased our result, 70%. And we deployed 27,000 cloud resources in a record time, and we support 1,700 applications, just this pattern alone, while keeping it secure, consistent, and compliant. So a few lessons that we learned along our journey. Start small, standardize, and automate relentlessly. Pick one bottleneck and automate as much as possible from start to end. And adopt modular and flexible design. Don't over-engineer your modules. Don't make it over-configurable. Make it just enough for your template to function, and then evolve accordingly. And apply team topology and agile ways of working. This is very important. So we deal with multiple different teams: security team, dev team, science team, data team, compliance team. So all of them have to work together for making incremental progress. Team topology have helped us to streamline our teams together. Have clarity on the patterns that serve majority of the use cases. If you're targeting to serve 100% of all enterprise use cases, good luck. It's never going to happen. You will definitely have a lot of snowflakes, so you have to deal with them separately. And embed AI in platform engineering workflow effectively, be it policy checks, coding assistance, and whatnot. And this is my favorite. Developers always take easy path. So if you make the easiest way, the right way, then you have the right outcome. So I want to leave you all with this. Your developers' creative work truly begins where their wait time ends. Thank you so much. Have a wonderful rest of the conference.
Good job. Take care. Grab that. Thank you. All right. Thank you, Sunir, for the talk. Appreciate it. It seems like World Bank's actually been some busy bees there. All right, everyone, guess what time it is? Lunchtime. All right, so don't forget, we have our Women in Tech luncheon going on soon. Also, that's in Storehouse Building D. We also have the general lunch. That'll be in the Hub Level 1 Gateway Pavilion. That'll go until 2 o'clock. Also, while you're there, please visit our sponsors, product demos. If you want to check out Terraform Stacks, it's all there in the HashiCorp zone. We have our certification exams. We got Robo Rally, Escape Room, Art Plotter, Swag customization. We got all that, okay? And also, we'll be back here after lunch at 2 o'clock for more technical deep dive sessions. Take care.